Here's my project for tutorial 11 using a piezo. And what the project is it's a model Morse code transmitter. A button here and a piezo there under that bottle cap so that when you press the button, it sends a Morse code signal to the piezo. The components I've used in this project are a battery, a momentary contact switch, a 10 ohm resistor, a blue LED with some electrical tape wrapped around it, a photoresistor, a 10,000 ohm resistor, a bottle cap, and a piezo speaker under the bottle cap, and the Arduino Mega 2560. Here you'll see more in depth how the project works along with a drawing of all the components working together. So here we have a battery, a 3.3 volt battery, wired in series with this button and this LED, and this LED is a blue LED that I wrapped in electrical tape to sort of direct the light straight so it doesn't spread everywhere. It directs onto the photoresistor when it's pointed at it. So we have the power coming in through the LED, out into this 10 ohm resistor, into this button, and back into the battery's ground. So that when you press the button, the circuit is complete and the light shines, and when you let go, the circuit is not complete and the light does not shine. On the other side, we got two main components, the photoresistor, and under the bottle cap is the piezo speaker. So how the photoresistor works is it gets power along this red cable from 3.3 volts of output on the Arduino board. And it comes into the photoresistor and out through this 1000 ohm resistor and through ground into this strip. At the joint where the photoresistor goes to the resistor, there's another cable going into an analog input in the Arduino. And what this does is that will bring the value of the current from the photoresistor circuit into the board and give an analog value. So the more resistance that the photoresistor applies, the bigger the value will be, and that resistance is determined by how much light the photoresistor receives. The piezo gets its power from this yellow cable, which comes from a digital output on the Mega board, and that will give a signal when the code tells it to. So it will give power, I believe 3.3 volts, when the code tells it to, and it goes into the anode of the piezo, out the cathode, and through this cable to the ground strip, which the photoresistor also goes into, and this strip is connected via this black cable into a ground port on the board. Now you may be wondering how a piezo speaker works. So at the core of the piezo speaker there is a piezoelectric crystal that when it's compressed releases an electrical signal. So here you would read current if this material is compressed. It also works in reverse. If you flow current through the material, it'll expand, contract. So in the speaker, you have the material here with a cone or system to amplify the sound, and when you run current through the crystal, there's a lot of different configurations. It's just a simple one to see. It'll vibrate and produce sound waves. Now we got the actual schematic of the project alongside the drawing that I showed earlier. Starting off with this side, we have the battery that goes to the LED through a resistor to the button and into the ground of the battery. You can see here you got the battery, you got the positive end, it goes into the LED through the resistor and around here into the push button or momentary contact switch, and then comes out through here into here, which is the ground of the battery. And then on the other side, we got the Arduino board, and we got power coming into the photoresistor, and both into an input on the board and through a resistor into this strip, which is grounded on the board. And we see that here, got 3.3 volts coming through the resistor, through the photoresistor, through the regular resistor into the ground, as well as into the input, with this branch here corresponding to this branch here. And then for the piezo side, we got the output from the board coming into the piezo and then out of the piezo into the ground. And we see that here, the output into it and out through the ground. Here's my code written in C++ in the Arduino IDE. And as you can see, it's very simple, pretty short. In the setup loop, I'm setting the digital input output pin 9 as output because it'll be used for the piezo, and I'm initializing the serial monitor to be used at 9600 frames per second, or per minute, sorry. Then here in the void loop, I start off by creating a variable called photores, short for photoresistor, just to replace the reading from analog input 0, which is where the photoresistor leads into, just to make it easier to type out. I don't need to type out this every time I want to use the value. And here I'm printing that value to the serial monitor and delaying for 50 milliseconds so that it's legible. And you can see that printing down here. Down here I have an if-else loop, which if the photoresistor gives a value greater than 415, play a tone through digital output 9, else don't play any tone. So what this means is if the photoresistor is inputting light greater than a value of 415, it'll play this tone through the piezo speaker. And if it doesn't, it won't. So basically, I've measured this to be the ideal number for when the LED is turned on, that it will play the noise, and if it's below that, meaning that the LED is not turned on, it won't play that. And that's the end of the void loop. Here I'll show you the project working alongside the serial monitor printouts of the value that the photoresistor is taking in, so you can see how it affects the piezo being played. So right now, you can see that the LED is not on, and the value is hovering at around 270 or so. Then when I press the button and the LED turns on, the value jumps to about 440, 450, and the piezo turns on. And when I turn it off, it goes back down, it goes up and down, corresponding to the light being taken in.